Hi, Algebra 1 students. This is Miss Penn. The first part of these notes is going to be summarizing what we've been working on in class, which is factoring completely, or combining methods of factoring, which is lesson 4 in module 4 of your Eureka workbooks. So what I have for you here at the top of your notes sheet is a little flow chart, and it can kind of help you go through the thought process of what questions should you be asking yourself at different steps when you're told that you should try to factor a polynomial expression completely. Okay, so if you look at the flow chart, we're always going to start by thinking about the GCF. So you're always going to ask yourself, is there a GCF? And if there is, you want to take out the GCF first. So if I look at example 1 down here, 12x to the third plus 33x squared minus 9x. So I'm asking GCF. Having some technical difficulties. GCF. And looking at 12, 33, and 9, I can tell that they all have a 3 in common, right? And so I know that part of my GCF is going to be a 3. And then I also want to think about the variables. So looking at the x's, I see I have an x to the third, an x to the second, and then just an x. So that means that they all have at least one x that I could take out. And then I want to think about, okay, what is left over? So I would have 4x squared plus 11x minus 3. Just to kind of complete the thought process. So we ask ourselves, GCF, it's 3x, right? So now what we're looking at is we're kind of zooming in on what's inside of the parentheses. So let's kind of like highlight this, the 4x squared plus 11x minus 3. And if you kind of look at the next part of the flow chart, we can either go left to binomial or right to trinomial. And looking at what we have a trinomial because we have 3 terms, right? The 3 terms being the 4x squared, the 11x, and the negative 3. So that means we want to go to the right on the flow chart and consider the 2 different methods when we have a trinomial. And we either have a is equal to 1 or a is not equal to 1. So when I look, and I'm looking specifically inside of the parentheses because I'm kind of, the GCF is still, of 3x is still out front, but I'm just kind of ignoring it and I'm kind of really focused in on the inside. So what is my a value in this trinomial? My a value is this 4. So in this case, that means a is not 1, right? So kind of to track our progress, GCF, maybe it's a good idea to write it here. So GCF was 3x. Then we came down and said we had a trinomial, right? And then a was not 1. So what does that mean? That means we have to do what multiplies to a times c and adds to b, or you could use the reverse box method, or in my class we also learned factoring by grouping. So I'm going to do it by factoring by grouping. So first things first though, I'm going to set up my x. And so because a is not 1, I need to try to think about numbers that multiply to a times c. My a is 4, my c is negative 3, so negative 12, and add to b 11, my b value. Right? So quickly, that's not too hard to think of, right? We can do positive 12 and negative 1 because they multiply to be negative 12, they add to be positive 11. Okay, so factoring by grouping says we're going to split the 11x into 2 terms, into a 12x and a negative 1x. So I'm going to kind of do this off to the side. So we had 4x squared plus 11x minus 3, and then I'm going to take the 11x and split it into a 12x minus a 1x. And then I'm just going to bring down the 4x squared, bring down the plus sign, bring down the minus 3. Okay, so now we're going to factor by grouping, so that means we want to group the first 2 terms together in parentheses, and the second two terms together in parentheses. Now, when there's a negative sign here, you have to be careful. So my recommendation is to treat this like we're adding a negative one. So I'm going to add like a plus sign, then the parentheses, then the negative sign, because otherwise you're going to mess up your signs here. Okay, so now that we've grouped, I'm looking for the GCF within each term. So that would be between 4x squared and 12x, that would be 4x I could take out. And then what's left over is x plus 3. In the second binomial, I could take out a negative. It looks like that's all I could take out would be a negative 1, right? Because 1 and 3 don't really have anything in common. There's no x's with the 3. So I'm just going to take out a negative 1, which I can do. And now what is left over? Well, I used to have a negative 1x here. So I took out the negative 1. All that's left is a positive x. And then I took out the negative from the 3, so I say plus 3. Now, what do you know? If you look at these two binomials, they are the same, x plus 3, right? So if you imagine we have two terms here. This part is a little bit hard to kind of visualize, but we have this first term here, which is the 4x times x plus 3, and then you have subtracted by another term, right? And so the idea here is that each term has a common factor, which is that x plus 3. So you can take the x plus 3 and it's factored out like it's a GCF. I could write x plus 3 out front, and then what's left over is everything written in purple. So that would be my 4x minus 1. Okay, and if we were to multiply this back through, we should see that we get the original trinomial of 4x squared plus 11x minus 3. One last thing, though, to get my final answer, I don't want to forget to write the GCF out front. So if we go back, I know it was a while ago, if we go back way to the beginning, the GCF was a 3x. So I want to add that back in. Okay, so now we have our completely factored form of 3x times x plus 3 times 4x minus 1, and we have completely factored it because we've kind of made our way through the flow chart, and now we are done. Whew, that was a long one. Okay, so now let's move on to the second example. And the second example is 7x to the 4th power minus 63y to the 4th power. So once again, we're kind of following the flow chart, and the first question to ask is there a GCF? So, and I'm looking between, I see x's and y's. So there's not a common variable there, but they do have a common number because 7 goes into 63 9 times, right? So the GCF is 7. So we're going to take out a 7. And then what's left over is x to the 4th minus 9y to the 4th. Okay, so now I'm going to go back to my flow chart and see how this can help me. Is now I'm thinking, okay, zooming in on what's left over inside of the parentheses, is it a binomial or a trinomial? Well, it has two terms. It has the x to the 4th and it has the negative 9y to the 4th. So those are two separate terms. This is a binomial. So if it's a binomial, then I need to think, is it a difference of two squares? And it's kind of, so that's a question mark, not a 2, sorry. The idea is, can I write each of these terms as something squared? So I like to do these little parentheses squared because it helps me think about it. So I'm thinking, like, what could I put inside the first set of parentheses that when I square it, I get x to the 4th? I could put an x squared in there. Because x squared squared is x to the 4th. And then for the 9y to the 4th, well, y squared squared would give me my y to the 4th. And then 3 squared would give me my 9. So 3y squared altogether would give me 9y to the fourth. Now, when I'm going to factor, that tells me it should do a plus b, a minus b. So x squared is my a, and 3y squared is my b. So I'm going to factor this as a x squared plus b, 3y squared, times a x squared minus b. b is 3y squared. Okay, and then I don't want to forget the 7. So kind of like write yourself a little reminder. Don't forget the GCF. Okay, in our final answer, you want to make sure that GCF is a part of your factored form. Otherwise, you don't have a completely equivalent expression. Oh, one other thing I forgot to mention here is if we're like following the flowchart and we're at difference of two squares here, after we broke this down, if you take a look at each of these, x squared plus 3y squared and x squared minus 3y squared, you could think that maybe one of those could be factored further because they're both still binomials and they have exponents higher than 1. So you could try to see if either of those are a difference of two squares, but here the first one is not a difference because it's a sum. You have the plus sign. And the second one is subtraction, but 3 isn't a perfect square here. So we can't do anything more, okay? So let's move on to the second part of our notes, which are on the zero product property. And this is gonna, hopefully this will go a little bit quicker. So this is actually a review of something we did in the, I think module 1 actually. Okay, it's called the zero product property, and it says, this, you actually do have notes on this already. It says if a times b equals 0, then you have two situations. Either a must equal 0 or b must equal 0, because they have to multiply together to be a multiplication of 0, so one of them must be 0. Okay, so example 1 here, x minus 3 times x plus 3 is equal to 0. This is an example we've actually seen before, but notice that the left-hand side of this equation is a factored form of a polynomial, right? And the right-hand side, we just have equal to 0. So this is actually relating what we've been doing with factoring to what we were doing before with the zero product property. And the idea is that if x minus 3, that's like one factor, times x plus 2 is equal to 0, then x minus 3 is kind of like the a above, and x plus 2 is kind of like the b. So that means one of those two things must equal 0. So either x minus 3 equals 0, in which case I could add 3 over to the other side, and I'd get x equals positive 3, or x plus 2 equals 0, in which case I could subtract 2 over and get x equals negative 2. So the zero product property, if we have a factored form, is equal to 0, we're able to actually solve and find solutions. So in the next example, we have 3x squared plus 9x is equal to 0. So we have our equal to 0 again, but I don't have an a times a b equal to 0 because I have a plus sign right here, right? So the key is that if I can factor this polynomial expression on the left, then maybe I can get it to be something times something else, and then I can set each factor equal to 0, and I have the ability to solve for x. So taking a look at this polynomial, we have a 3x squared plus 9x. So I want to still keep my flowchart in mind and first think, is there a GCF here? And the answer is yes, it's 3x. So I would factor out a 3x. What's left over is x plus 3. And that's all equal to 0. Well, now what's inside my parentheses is a linear binomial and just an x plus 3. So I don't even have to think about if it factors any further. I can just take each of those two. So we have a factor of 3x and a factor of x plus 3, and I can set each of them equal to 0. This is 3x is like my a in the definition, and x plus 3 is like my b. So in each of these, in 3x equal to 0, I could imagine like dividing by 3, and then I get x is equal to 0, because 0 divided by 3 is still 0. And then here I just subtract 3, and I get x is equal to negative 3. And these would be my two solutions. Okay, so again, I was just following my factoring rules from the flowchart in order to break it down so that I could set each factor equal to 0 and solve for x. Okay, let's look at the next example. So in the next example, it looks very similar, 3x squared plus 9x, but now I don't have it equal to 0, right? So this is a problem. So if we don't have it equal to 0, we can't apply the ZPP. So we have to get it equal to 0. So if I'm looking here, how can I get equal to 0? Well, I'd have to add 6 over to the other side. And I'd get 3x squared plus 9x plus 6 is equal to 0. Now I can think about factoring. So now I can try factoring. So again, I'm following the flowchart and I'm looking, and I can tell there is a GCF here of 3. So I would factor out the 3 and get x squared plus 3x plus 2 equal to 0. Okay, now following the flowchart, I have a trinomial and a is 1. So that means I can just use the x. I don't have to do anything more complicated. I just need what multiplies to c and adds to b. So my c value is 2, my b value is 3. The numbers that multiply to 2 and add to 3 would be 2 and 1. So then I get x plus 2, x plus 1, and I bring down the 3, which was my GCF. Okay, so now we factored this completely, and we need to set each factor equal to 0. So it's not just an a times b now. We have 3 different factors. We have the 3 out front, the x plus 2, and the x plus 1. So actually I'm going to set all of them equal to 0. So this 3, though, if I set it equal to 0, well, 3 will never equal 0, and there's not even a variable there. So that's not true. So it doesn't even give me any solution. Okay, so that we can just kind of ignore it. So now bringing down the x plus 2, I would subtract 2 over to the other side and get x equals negative 2. And then kind of type for space, I'm going to do the x plus 1 over here. Subtract 1 over and get x equals negative 1. So those would be my two solutions there. Okay, one final problem. Example 4 has x minus 2, x plus 2 is equal to 2x squared plus 6x plus 4. So it looks like I have a factored form polynomial equal to a standard form polynomial, and I'm not exactly sure what to do, but I know that if I want to use ZPP, I need to get this equal to 0. So I want to get standard form, basically, which means I'm going to have to multiply the binomials on the left. So we need to get equal to 0, but we're going to multiply first. So multiplying on the left, I actually know, because this would be a plus b, a minus b, it's gonna, my 2x and negative 2x would cancel when I do my multiplication. So it's just going to give me x squared minus 4 is equal to 2x squared plus 6x plus 4. So if I want to get it equal to 0, my easiest thing would be to move the x squared and the negative 4 over to the right. So I'm going to subtract x squared and add 4, kind of doing two things at the same time. So here the x squareds are going to cancel, the negative 4 and positive 4 are going to cancel. So I'm going to get my equal to 0 like I want. And on the right hand side I'm going to get x squared plus the 6x just stays as 6x. And then 4 plus 4 is 8. Okay, now that I was able to, now after I multiplied and I got it into standard form, now I can try to factor this polynomial. So again, there's not a DCF. I'm thinking about the flow chart. There's not a DCF. It's a trinomial, and a is 1. So that means I can just easily set up the x. 1 multiplies to 8 and adds to 6 is 4 and 2. So it's x plus 4, x minus 2, sorry, x plus 2. And then you might have caught on by now, but the solutions end up kind of being the opposite signs of the factors. So like I'm going to get x equals negative 4 here, and this one would give me x equals negative 2. Okay, sorry this video was a little bit longer than usual, but I did not give you any you try problems, so you can thank me for that.